All right, so this problem we got to take the derivative, and if you notice, it's written as a product, and each of these factors is actually they're second degree factors, right? They're raised into a power in and of themselves. So we can think of this as a product rule where we've got like f times g, and then both f and g are composed, right? Because you got an inside piece, in this case 5x minus 1, and the outside piece squared. Over here, the inside piece, 4 minus x to the fourth squared. So this could be seen as a product rule, where, you've got to take the derivative of product. So you'd have the derivative of the first factor times the second plus the derivative of the second factor times the first. Now, because these are only exponents of 2, if you're comfortable with squaring binomials, they're both binomial factors and we're squaring them, it's not actually that much work because they're just exponential. If they'd be exponents of 5, 10, whatever, then we would definitely go down here to the product rule. But we can actually write this as a collection of terms, and maybe that's convenient, maybe not. Let's see. So if you square this binomial, just as you can always FOIL, right? But I'm assuming if you're going to go this route, then you're probably pretty confident with squaring binomials and just FOILing in general. So that's the form for squaring a binomial. So if we square this 5x minus 1, right, we're going to square the first term, gives us 25x squared. We're going to multiply the 5x and the negative 1 together. That gives us negative 5. And then we're going to double it. There's the 2. So we're going to get negative 10x in the middle. And then you square the negative 1 to the positive 1. And then if we square the second binomial, we get 16 minus 4 times negative x to the fourth is double that, you get negative 8x to the fourth. And then if you square x to the fourth, you're going to get, in this case, positive x to the eighth. Like that. And then you can distribute these terms here. Now, that being said, I'm looking at this and I already don't actually like it. Because, I should have considered the fact that you square a binomial and then you end up with the result's going to be a trinomial. And now if we want to use the power rule, we're going to have to multiply these two trinomials, which doesn't really look that much fun to me. It could be done. So I'm going to go back on what I said, and I actually do not like the strategy of going for the power rule here, but I'm going to leave this because it's a good example of like what to consider and why like the product rule is necessary. Because in particular, it wasn't such a big deal if this was just 5x minus 1 times 4x minus x to the fourth, but they've got these additional factors, these exponents, which can make the algebra a little tedious if you're trying to go for the power rule. So that's why the product rule is going to be a better route here, I would say. And you could say, oh no, I don't like the product rule. I'd rather do all that algebra. That's fine. But let's take a look at this and we'll see. Hopefully you'll see it's a little easier. All right, so if we take the derivative of f, which is this whole first factor here, f prime is the derivative, notice it's a chain rule, right? We bring the exponent down, rewrite the inside, reduce the power, so now it's a 1. And then multiply by the derivative of the inside, the 5x minus 1. So its derivative is 5. Then we multiply by the second factor, the whole thing, 4 minus x to the fourth squared. And then our next term is going to make some room here. Ooh. Moving things is always complicated on Zoom here. Okay. So the next term, put a plus sign here. We're going to take the derivative of now the second factor, g. And again, that is a composed factor, right? We got inside, outside. So we'll use the chain rule. 2 comes down in front. We rewrite the inside. Reduce the power by 1. So now it's to the first power. I'm just going to fix this parenthesis here. I'm not going to put the 1 here. We don't need to raise it to the first. It's just to the first power implicitly. And then we multiply by the derivative of the inside, which is the derivative of the 4 minus x to the fourth, which is minus 4x cubed. So that's the whole derivative of the second, and then we got to multiply by the first again. So that's 5x minus 1 squared. Now, when you start combining the product rule and the chain rule, sometimes it's easy to get lost of where you're at, so it's helpful. I'm going to at least write this out. So this whole thing was the derivative of the first factor, f prime. Then we had the second factor just coming along for the ride, right? We'll call that g. Now, we put the plus sign in. It's plus. Now we're taking the derivative of the second factor, which is this whole thing was a chain rule. So this got multiple factors here. And then it was times the first, which we called f. So there's all the pieces. Hopefully you can connect the dots there as far as how we get from here to here now. If you didn't already see them as we worked. And now This is a suitable answer. Really, as far as I'm concerned, it might make sense to like multiply 2 times -4. Actually, I'll reduce it to at the very least what I'd like to see. So we got 2 times 5 makes 10. Then we get the 5x minus 1, 4 minus x to the 4th squared. 2 times -4 makes a -8x cubed. 4 minus x to the 4th. 5x minus 1 squared. So this is a suitable answer. Now, let's say you got this wrong in the homework or something. They would give a more simplified answer. So just to show you how they would get that, let's see. We can start by pulling out a greatest common factor amongst these two terms. There's one term here, one term here. So amongst those two terms, if we start with the numbers, 10 and 8, the coefficients, right, we can pull out a 2. Now, 5x minus 1, we've got one factor of it here, and we've got 2 factors of it over here. So at most, we can pull out one factor. When we get to this factor here, 4 minus x to the 4th, we've got 2 of them. It's being squared, and we've got a single factor to the first over here. So we can pull out, again, at most 1. And that leaves behind now, in parentheses, we pulled out a 2. So we now, from that 10, so now we got a 5. We pulled that out, it's gone. But we did leave behind one factor of 4 minus x to the 4th. Now we get the minus sign, and we pulled a 2 from that 8, so that's a 4x cubed. And we pulled out the 4 minus x to the 4th, and we did leave behind one factor of 5x minus 1. So really all that's left to do now is combine like terms. Let's see. It should be good as it is. The order in which you write these terms doesn't matter as long as they're combined. Like I'll do it in a separate color. So 5 times 4 makes 20, negative 5x to the 4th, minus we've got 20x to the 4th, and then we've got plus 4x, right? That's negative 4x times the negative 1. So we're distributing, and then if you combine like terms here, again, the order, addition is what's called a commutative operation, meaning you can add in any order, right? 5 plus 3 is 3 plus 5. 5 plus negative 3 is the same as negative 3 plus 5. So it doesn't matter really what order you write them in. So the answer that they give might be different from the order you got, and that's perfectly fine. It's inconsequential, I suppose. So we do need to combine like terms there, right? Like we've got negative 25x to the 4th. We've got a positive 4x, and we've got a positive 20. Again, that's the order I'll write it in. Maybe they've got the 4x out front, and maybe they've got like 4x minus 25x to the 4th. That's the same difference. So this should be the best answer here. I don't see anything else. Sometimes it's something sneaky where, like this, for instance, here could be factored. I don't see any reason to do that, but I'm just considering the types of factors that might show up as answers. Like, again, you can factor this piece here as that, but there's no reason to do that. That being said, you may even be able to factor this piece if you were to consider common factors. I'm looking at it, I don't see anything, but that being said, you don't need to do all that factoring. There's no reason for it. We're not working with it anywhere beyond that. We're just trying to get it to a form that's manageable and legible. So hopefully that helps. If you were going to submit this as an answer, by the way, this would be fine here, and the test would take it, or the homework, whatever you're working on. Like I said, if you get the answer wrong, though, they're more likely to give you just a more reduced version, something like that. Okay, hope that helps, and take care. Thank you. Bye.